Welcome to our minute video on entropy by Mikey Taylor
and Jet Patamavong.
What is entropy? In chemistry, entropy is the measure of molecular randomness or disorder. This object is highly ordered, so it has low entropy. Then, it transforms to an object with a lot of disorder, so its entropy increases.
How is it calculated? We can calculate the overall entropy of a given system using Hess's law, but using entropy instead of enthalpy, otherwise known as heat. Change in entropy equals the summation of the entropy of the products minus the summation of the entropy of the reactants.
The second law of thermodynamics. The second law of thermodynamics states that the state of entropy of the entire universe as an isolated system will always increase over time. The second law also states that the change in the entropy of the universe can never be negative. In this picture, this block of ice is very organized, as all the individual atoms are locked in a lattice. Over time, all the intermolecular bonds break and it becomes a puddle of water. Now the molecules slide freely and are not locked in place, therefore it has a higher entropy. In order to decrease the entropy and freeze the puddle of water, you need to use outside energy, like a refrigerator.
Why does this happen? Entropy is inevitable because of statistics. There are so many possible configurations of disorder over ordered states that it is almost statistically impossible for entropy to decrease on its own. When you throw a bunch of bricks onto the ground, it is statistically likely to be in a jumbled mess than an ordered column. Even when it may seem like entropy has decreased, the overall entropy of the universe has increased. For example, Miss Nichols could be stacking books after school has ended, and it'll appear that she's making the system more ordered. In actuality, she is burning energy and releasing heat, which increases the overall entropy of the universe.
Using the standard state entropy data table, we can find the change in entropy of the reaction. For the product NO, there are 2 moles of it, so we can multiply the number of moles by the value given in the table, which will give us the summation of the entropy of the products. Then we can do the same thing for the reactants, N2 and O2, both of which have only 1 mole, so we can just use the value given. We take the summation of the entropy of the products, NO, minus the summation of the reactants, N2 plus O2. Adding all of this up will give us 24.77 joules per Kelvin.
Thanks for watching!
And now for our citation.